welcome to my channel again. So in previous video we did some exercise questions of exercise 1.1 and our concepts got cleared by watching some examples and also the questions of that exercise. Today in this lecture I will teach you that there are some types of set, which means like in real world, if a person is chubby, then we say that he is a chubby kind of person. Similarly, there are some characteristics, or we can say there are some criteria for becoming a particular type of set. Okay, so these are some types of sets that we are going to cover in next topics. And one more thing is that what will be the order of covering these types of sets will be this. How I numbered the following sets will be their order of covering. And one more thing is that equal set, subsets, power set, universal set, all these four sets require a comparison thing, like there should be two or more than two types of sets for naming a particular set. Like if a set is power set, so there should be two or more than two types of set that we are naming it as power set. Meanwhile, empty set and this set, these two types of set does not require any more number of set. They are named in their individual itself. Okay, so let's see empty set. So the characteristic of this set is in its name only. Okay, like the characteristic or the property of the set is hidden in its name itself. Okay, so as its name saying, the set will be empty. That means the set will have no element. Okay, set will have no element. And you know, this set is represented by which symbol? Let me tell you. Either this or this. Between these two symbols you can use any of them. This symbol is called phi. Okay, and also this set which has no element, the set which has no element, it is also called as null or void set. Also called null or void set. Okay, like we have an example in NCERT book, like here is a set written in set builder form, like x says that x is a natural number and x is greater than 1 and x is less than 2. Okay, if we see, there is no element between 1 and 2 which is a natural number, because 1 is itself a natural number, 2 is a natural number, and between these two will be a real number but not a natural number. Okay, so in this set there will be no element. So set A will be represented by this symbol or this symbol. Okay, another type of set is finite or infinite set. Finite and infinite set. Okay, finite set, and here will be second part. Second type of set has two parts: finite set and infinite set. Here will be infinite set. Their name are itself their proof of their characteristics. So finite set will have finite number of elements. Okay. Any set which has finite number of elements, that means we can list them in roster form. Okay. And in infinite set, the name is itself a proof of its characteristic, that there will be infinite number of sets. That means the elements in the set cannot be listed in roster form. Okay. Okay. That means we can list them, but not all the elements can be listed. Like we will have to write A, B, then dot dot dot. This will be the representation of infinite set. And for finite set, there will be like A, B, dot dot dot. There can be dot dot, but there will be an ending element. Okay, like C, not C, will be E and F. Okay. This is infinite set and this is finite set. Now we are proceeding towards those type of sets which require a comparison. First one in that category is equal sets. The name itself is the proof of the property which the set will be holding. That means we should have two or more sets so that we can name them as equal sets. Okay, so in equal sets, two sets are equal, two or more sets are equal if the number of elements, the elements itself, the elements themselves all are the same. That means if there is a set A equal to holding elements 1, 2, 3, 4, and there is another set called D, it is also holding the same elements 2, 3, 1, 4. No matter what is the order, because if we write A in this order also, then it will be A only. Okay, it will not change because order does not matter. I have taught you this thing in my previous lecture also. So A, set A and set D, set called A and set called D, both will be equal. A is equal to B because each element and the number of elements are same. That means, and also if the number of the elements are same, then obviously the number of elements will also be same, because there is no element in D which is not in A. Okay. And there is a similar concept called equivalent sets. Let me teach you that also. Sets. In this category, the elements, there is no compulsory situation or compulsory requirement that the elements that are under the set should be same, but there is a condition that the number of elements should be same. It is not required that elements also should be same, but the number of elements that are in the set should be same. Like if A would be holding 1, 2, 3, 4 and D would be holding B, C, D, E, then we would have said that A and D are equivalent sets. That means they have same number of elements. It does not matter whether they have the same elements or not same elements or different elements. Like A and D would be called equivalent sets in this example. In this example, A and D would be called as equivalent sets because they have same number of elements. We are not seeing whether they have same elements or different elements. The number of elements in both the sets are same, so A and D are equivalent sets. So we can say from these both examples that all equal sets are equivalent. But vice versa is not true. So our next topic is next type of subset is subsets. It is another type of sets which require a comparison type of thing for the set to be named. Okay, so if there is a set A 4, okay, this is set A, and the second set is B, so here we have set A and set B. So here set A is the subset of set A. That means it is set B. Set A is subset of set B. That means set A is the part of set B. When I am saying that set A is the part of set B, so it means that if we choose some random elements 4, 8, 12, 16 and form its set. It is set A in our example, and when we form its set, then it is called as subset of B because the elements are chosen from this set. All the elements of this set is from the elements which is chosen from set B. Okay, like set A is the part of set B. If we choose some elements, some more other elements from set B like 2, 6, 8, 10, then this is also a subset of B because all its elements are in set B. None of its element is that which is not coming under set B. Understood? So for subset, there should be at least two sets to be present there. Let's, if it is a set A, let's name this set as set C. Okay, so these two sets are the subsets of B because there all the elements are coming from set B. No element is that such that it is not in set B. Okay, we will have to discuss subsets, that means this type of set, in detail because it is so important in this chapter. So let's see that thing. If we have a set, assume it is to be 1, 6, 4, 8. This is a set. Okay. So let's see if this is a set. If this is a set, so how many subsets and which subsets would be formed for it? Let's see. First one would be this null or void set, which we covered previously in previous slide. So it will be the subset of this set because is there any element in this which is not coming in this set? No, because there is no element in this set which is not present in this set. Okay. So this will be one of the subsets of this set because there is no. I told you the trick. What is behind? I told you the trick which is behind this. Okay. And second one subset would be this. Okay, because in this set, this whole is a set. Okay, this whole is a set. So this whole is a set. So then this will be its element. This set's element, which is 1, is all the elements of this set. Okay, and there is only one element which is 1, which is coming under set A. That means there is no elements in this set which is not in set A. So this will be subset of set A. Okay. Another one will be this. Similarly, 6. Second one would be this. Next one would be this. These are so simple. And now let's begin the second thing. So another one would be 1 with 6. Okay, 1 with 6. Another second one would be 1 with 4, then 1 with 8. Either you write 6, 1 or 1, 6, both are the same thing because that will be a same set. So there is no there is no means of writing this thing twice 1, 6 and another set as 6, 1 because it will be the same thing. So 1, 6 is done. Another one would not be 6, 1. The next one would be 1, 4. Another one 1, 8. Then 6 with 1. It is already done. 6 with 4. No, I mean 6, 4. Note that there will not be 6, 6 because repetition is not allowed in the sets. Remember, 6, 4 is done. Next one would be 6, 8. And furthermore would be 4 with 1. It is completed. 4 with 6 also completed. 4 with 8. 4 with 8. Okay. Then 8 is being almost done with everything. 8 with 1 also, 6 also, and 4 also. 8 comma 8 will not be valid. Okay. And then subsets with one element done. Subset with two elements are done. Let's see 3 element subset. Okay. 1 with 6 and 4. Then 1, 6, 8. Another one would be 1, 6, 8 is already done. Then 1, 4, 8. 1, 4, 8. Because this is a new set. I mean subset. Then will there be any element as 1, 8, 6? It is already done. It is now completed. Let's see with 6. 6 with 1, 4. Done. 6 with 1, 8. Done. And 6 with 4, 1. Already done. Then 6 with 8, 1. Yeah, it is already done almost. All the subsets with 3 elements are completed. The next and the last one would be this. 1, 6, 4, 8. It is also the subset of set A. Understood? So here comes our very important note that every set is the subset of itself. Understood? Every set is the subset of itself. Okay, power set. Our second last topic of types of set. It is like, let me write an example so that it becomes easy to explain you. Like if there is a set A equal to 1, 2, what will be subsets? I have taught you just. Okay, so its subsets would be this, 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 and this. These all are the sets. If we make a set of these subsets, then that set will be called power set. That means writing it under a curly bracket. These curly bracket forms a set, and the things which are separated by commas, that means these are the elements of this big set. This big set is called as power set. Okay. Our next type of set is universal sets. Universal sets. If we have two or more sets present over there in that particular case, Then let me give you an example first so that our further things get clear very easily. Set A is 1, 2, 3. Set B is A, B. Set C is like 4, 6, and set U is equal to 1, 2, 3, 4, 5, 6, A, B, C. This is the big set. Set U. Generally, universal sets are represented by capital U. I said generally, not in every case, but generally. So, these are the elements under set U, and set A 1, 2, 3 is present in set U. A, B is also present in set U. 4, 6 is also present in set U. The set which is consisting of all the elements of the present other sets. The set which is consisting all the elements of other sets which are present in the case is called an universal set. This is the universal set 1, 2, 3, 4, 5, 6, A, B, C. And set A is consisting only these elements, and B is consisting some other elements, C is consisting some other elements, and maybe some 1 or 2 elements may be left over in set U, but set U will be called here as universal set because it has all the elements. It is consisting of all the elements which A, B, C possess over here. So, universal set can be defined as a set consisting of all the elements which the other sets are possessing. Okay, we will see some Venn diagrams which are our next topics in other videos, and we will again see universal sets, power set, and equal sets things again in while studying Venn diagram, because it requires the study of universal sets, and most generally, or you can say in more aspects, or like in universal sets topic is more relevant to Venn diagram studies. Yes, okay. So when we will discuss Venn diagram in our future things, we will come over here again. So if you like this video, please hit the like button and stay connected for future videos.